Good morning. My name is Reya Singh, and this is my partner.
Hi, I'm Jaden Rohrs.
We want to start off by saying we hope you are doing well and staying safe during this time. I know it's been quite difficult for a lot of us, but we are making sure to do things to the best of our ability and breaking through as many barriers as we can. Also, a little thing to add, my partner actually has a board at her house, but what I have is an imported image, which Zoom allows that option when you first start the meeting. Okay, so to get into things, our big question is, can silver nanoparticles kill yeast cultures? This was a very, very intriguing topic. I'm going to start off by saying that, and I'm very happy we did it. But with every big question, there's always a hypothesis. You can always give your best guess, and we hypothesized that yes, the silver nanoparticles will kill the yeast cultures. This was due to our background research, although most of the articles were on silver nanoparticles against bacteria, more specifically E. coli, we figured that maybe it will have a good effect against the yeast. Our materials included a lab notebook, colloidal silver, isopropyl alcohol, jars, tweezers, sterile cotton swabs, a Sharpie, yeast, graduated cylinder, distilled water, pipettes, sterile discs, and agar plates. Our procedures, we mixed half a teaspoon of yeast with 50 milliliters of water. We then poured 22.5 milliliters of distilled water in jars 2 to 5. We had a total of 5 jars. They were all baby food jars, cleaned and washed out, and the same size. We then poured 25 milliliters of undiluted colloidal silver into jar 1. And this is where it gets important. We diluted the colloidal silver by transferring 2.5 milliliters of the silver from jar 1 to jar 2 and mixing and continuing the transferring of the 2.5 milliliters from each jar to the next. So if you think about it, the concentration is getting lower and lower as the jars go on. So jar 1 had the highest concentration of the colloidal silver, and jar 5 had the lowest concentration because as you go on, the majority of the concentration becomes water over time. We then let the sterile disc soak in the silver dilutions. We use sterile cotton swabs to distribute yeast onto the agar plates, and we placed 3 sterile discs on each plate. Finally, we let the plate sit and monitor the growth and made sure to record our observations in our lab notebook. Our variables, we had our independent variable, which is the different concentrations of the colloidal silver. We want to know how high or how low of a concentration you need to really see an effect, which brings us into our dependent variable. The effect would be the zones of inhibition. My partner Jane will tell you a little bit more about that later, but we wanted to see the zones of inhibition based on the concentration and finding the averages for each concentration. And our control variable to make sure our experiment was as accurate as possible were the agar plates, the amount of yeast added onto each plate, and the amount of water in each of the jars, and also the size of the jars. Now my partner Jaden will tell you a little bit about our extra testing and the new control, our findings, and our inspiration for this topic.
So, in addition to our main testing, we also did some extra testing. What we did differently for this testing was we lessened the yeast concentration to 1/4 teaspoon to 50 milliliters of water. We wanted to see if the amount of yeast was the problem and the silver was too weak to handle it. So the pictures is back here. And we did this 2 different ways. We did one with sterile discs that have been soaked in the highest concentration of colloidal silver, which colloidal silver contains silver nanoparticles. And we did it also without sterile discs, where we put 3 drops onto the plate directly. And also, a little extra piece of information. Our original control, we just put yeast on an agar plate and let it grow. But we received a recommendation to put plain sterile discs on a plate with yeast and compared our other plates to this one. This was much easier to compare and overall worked out better for us. So in conclusion, after we got all of our testing done, we realized that our hypothesis was not correct. This was because there were no zones of inhibition growing, and we believe that this is because the silver is more effective against bacteria and not fungus. So a little bit about zones of inhibition. this is what clear zones of inhibition would look like. As you can see, there are circles around the sterile disc, which sterile discs have the medicine, and the bigger the circle, the more effective the medicine is working against the bacteria or fungus. And what I mean by clear zones of inhibition is after we finished all of our testing, we found that on almost all of our plates, they had these little kind of like, they're kind of hard to see, these little like indents. Yes, like little indents of zones of inhibition in them. We believe that this is because it was somewhat effective against the yeast, but not entirely effective. Also, a little inspiration on how we decided on this project was actually the Norwex cleaning cloth. We wanted to do something involving Norwex cleaning cloth because this cloth actually has silver inside, so once you wipe down any surface, the silver will actually clean it and self-purify itself so it's ready to use within about 24 hours. And we knew we couldn't exactly test the cloth, so that's why we decided it'd be cool to do this experiment and test it against yeast because there was already so many findings on it being effective against bacteria. We also learned, overall, we just learned about all the different properties of silver nanoparticles, such as them being antibacterial and antifungal. And something that I find very important is that we both learned about how just because your hypothesis is incorrect doesn't mean your project is any worse. It just means you got different results from what you were expecting, and it actually is beneficial because you then know that it just wasn't effective. Like the silver, it was not effective against the yeast.
And also adding on to what Jane said, I feel like it brings you so much more knowledge because the fact that our hypothesis was incorrect triggered a lot of wanting to do more research for me. Once I found it was incorrect, I made sure I did a lot more research, and I feel like it's more beneficial for people, not just us, who use things like the Norwex cleaning cloth or silver in their day-to-day lives. Silver is used in the medical field. It's used in food to purify, and the findings that we brought were, I felt, so beneficial. We were talking to a teacher about our findings, and she actually uses Norwex cleaning cloth to, her family uses it to bathe. And she said, like, now she knows that if her kids get yeast on them somehow, it's not going to clean all the way in the shower. And also, yeast is so commonly used in the kitchen, and that's where you use the cloth to clean. So if you spill yeast all over your counter and you reach for this cloth to clean, you may have the expectation that all that yeast is gone and the silver nanoparticles killed all of the cultures. But in fact, it's not as effective based on our testing.